We are the paradoxical ape. Bipedal, naked, large-brained, long the master of fire, tools, and language, but still trying to understand ourselves. Aware that death is inevitable, yet filled with optimism. We grow up slowly. We hand down knowledge. We empathize and deceive. We shape the future from our shared understanding of the past. CARTA brings together experts from diverse disciplines to exchange insights on who we are and how we got here. An exploration made possible by the generosity of humans like you.
I'm going to assume that we've already talked about this phylogeny, but I want to remind everybody that now we know, which we didn't know not so long ago, how closely we're related to the great apes, that we now all belong to this hominid family. And some of them are actually closer to us than they are to each other. And yet, we look at them, we look at those great apes, and in every single case, it's independent mothering. Babies are already starting to eat on their own, even while they're nursing. And then when they're weaned, they get their own lunch. And then there's us. Now, I'm using this Hadza couple to represent modern humans. They are modern humans, but there is something special about them I'm going to continue to talk about. And the common story about what happened in our lineage is that moving into the savannah, hunting was a better way to make a living than living on the soft fruits and leaves of the forest. And so moms did better to pair with a hunting mate who then went off and hunted and brought home the bacon, and we get the sexual division of labor, and that paternal provisioning supported the kids. And so we get nuclear families as these units of common interest. And that continues to be a favorite idea about our evolution, but we have lots of chances to look at modern people. Again, it's only us moderns that are left in lots of places where they're living entirely on wild foods. That's special. Sometimes they're not. Sometimes they're just using wild resources. We can learn a lot from that because they know what they're doing. So we can see how they do it, what the problems are. But it's also the case that wherever we find modern people doing this, they're also using stuff that wasn't around a long time ago, like metal pots or metal axes or even shotguns. We can still learn from them, but there is a place in the world, one of the examples where people, when we were studying them, were entirely living on wild foods, except for a couple of % of things that came in from elsewhere, in a part of the world that's especially interesting because it's this part of Africa where we have such a deep record of our evolutionary history. And so here is a place where there's a long archaeological record. My colleagues, Jim O'Connell and Nick Blurton-Jones, one of them is an archaeologist, O'Connell, so he was especially interested in what the archaeology looks like, given that this is going on. And so we paid very close attention to every single big animal that was taken. He followed where every animal fell, how it was cut apart, what happened to the bones, all those things. And as a consequence of that, we had this fantastic record where we could calculate the chance of actually getting one of these big carcasses on any average hunter day. And these guys are very good, and they are modern people, and they're using bows and arrows, which weren't around if we go very far into the deeper past. And yet their capture chance on any day was way less than 5%. But when they hit, whoa, big bonanza. So these guys are sitting on a giraffe carcass. And the thing is, it was just one guy who hit the giraffe. They're all sitting there for their picture, but everybody knows who it was. And the story goes around, everybody knows. And not only that, everybody comes to the kill site to eat and take stuff away and to, as the Hadza say, help eat the meat. So, wow, this is no way to solve the problem of eating every day. And when it comes to that, what the women and children are doing is so important. So the story right here about it's all about a provisioning father, and that's the story that's so different from our closest cousins. We see that these little Hadza kids they're trying to go for the things that are the key resource year-round, these deeply buried tubers, but they're just too little to do it. So they try, and they still have to depend on their moms, which they do, and we could see it in the weights, until she has a new baby, as this woman does. And then she's still foraging, but she's got something else going on. And so now these kids, the weaned ones, now our weights showed that they were actually depending on their grandmothers. And key things about these resources that are so different from what these are our closest living cousins are eating. These guys, our closest living cousins, are starting to feed themselves while they're still nursing. Well, little kids cannot do it with these savanna resources. Adults can get high rates daily, predictable, every day. And the way in which it pays to forage is a little more effort, and your returns go up in this way, so that doing things in batches is the economic way to forage. So these older women, and here are some old Hadza women well into their 60s when these photographs were taken, they're adding to the batches. And we've got this gregarious foraging, everybody's there, these old women, younger women, all these kids. So the productivity of the older women is contributing to what's there, and these subsidize the fertility of the women who are still in the fertile ages. They can have the next baby sooner because the previous one is not going to starve. And so now when we look at this difference between us and our close cousins, chimpanzees, best data on great apes for life history comes from chimpanzees. And what we're looking at here is just the female side of the age pyramid. But here, chimpanzees, and so each one of these bars is a 5-year age class. And so what happens is mortality, and these green bars are the females who are still in their fertile years, they're still cycling. But if you're a chimpanzee female, you're likely to die while you're still cycling. It's very few that live beyond their fertile years. Our fertility ends at about the same age. But if you're human, then, and we're looking at Hadza folks to represent humans, so mortality is higher than it is in the populations that most of us live in. But here, even though mortality is higher, if you make it to be an adult, the chances of living beyond your fertility are way greater than even. And so what we see in human populations is that this enormous fraction of female years lived is post-fertile. And so over here, we've got these grandmothers whose work is allowing the still fertile females to have next baby sooner, because it's keeping the still dependent young ones alive. And we get a life history that goes with that. So very exciting that we get these pieces to fit together, the earlier weaning, the greater longevity, even though, and the later maturity, even though the end of fertility is about the same. So the question is, no, it sounds like it could have been that way, but ooh, could it really happen? And that's why so great to have Peter Kim, who's a mathematical biologist, get really interested in the question. Building agent-based models is one of his specialties. So this is the result of a series of simulations of an agent-based model in which the great ape parameters do not change. using chimpanzees mostly to estimate an ancestral condition. And things stay there. It is an equilibrium for 1 million years. However, there are 7 extinctions, which I may have a chance to say a little bit about. But if then one of these in his model is allowed to females, the very few, and it's a tiny number, who outlive their fertility, are allowed, their productivity is allowed to subsidize the fertility of the younger females, then this is what happens. 30 simulations when that's going on, and everyone, if they can escape the basin of attraction of that ape-like equilibrium, one thing happens, which is the simulation moves things to a new equilibrium with longevity that looks just like what we see with modern people living in this kind of mortality regime. And Peter's models have both sexes. So we were just talking about the females initially. So we were just talking about this side. Now, again, using Hadza folks to represent us. So the blue bars are humans and the green bars are chimpanzees. Ooh, apologies to the blue-green, colorblind folks. But one of the things that happens with this increased longevity is we are a two-sex species. Half your autosomal genes come from dad and half come from mom. And the increased longevity is happening on the male side. But reproductive physiology in mammals means those males are still producing gametes into those older ages. So now we got all these old guys. And that means that the sex ratio, and these brackets are marking the sex ratio in the fertile ages, is now male biased. And we know that this male bias it's common in birds, and we see pairing in birds. Actually, people started studying it in invertebrates. Wherever you see this male bias, what it favors as strategies in males is to guard a mate. Once you get one, hang on to that mate. And this idea about mate guarding as what's really going on in humans has been around for a while, but now here's another reason to think that might be what we're looking at here. And if it is, then for this guy to actually make a claim on a mate and get away with it depends on when the other guys will let him. And so his reputation as a hunter becomes hugely important because, boy, everybody knows about that. Everybody cares about that because they get in on the bonanzas when they happen. And so we see in the case of the Hadza or the Ache, these are foragers in eastern Paraguay and in South America, or the Alyaura, this is Australia, where, interesting different story there, but also the old men are the ones who manage to be running the show a lot. Their alliances are really important and dominate public affairs. But I want to underline another thing that goes with this longevity. And here I'm relying on Barbara Finlay's work, a neuroscientist who's been looking at variation in mammal brains all the way across the class. And what her continually expanding data sets show is that brain size is a consequence of developmental duration. So increasing longevity increases the time over which brains develop, resulting in larger brains, and those parts scale. So the size of our neocortex is just the size it would be for a mammal brain of this size. So here's a hypothesis about our brains being larger because they're developing more slowly. So they end up being larger than chimpanzee brains. And yet weaning is earlier. So we've got this difference, and yet those brains are being wired early on by being confronted with, oh, wow, mom's got something else going on. These shortened birth intervals. Moms, the hypothesis about this shift in life history is that mothers can spend less on each because somebody else is supplying crucial subsidies. And Sarah Hrdy has written so wonderfully about some of the consequences for infants and toddlers. The survival challenge under those circumstances is to attract somebody's attention, to engage others, to pay attention to me. Am I not cute? Am I not worth your time and support? And so our babies have been, according to this hypothesis, wired to be socially so precocious. Now, no question that human babies are, just babies. They can't really do very much motorically, but developmental psychologists have been working on these issues without using this framework to think about it and attending to this active engagement that characterizes infants in living people. And so here, the grandmother hypothesis that started out as a way of connecting, foraging for these resources, the kind of interdependence that, for example, modern people, the Hadza, display this division of labor between older females and younger ones, that could have resulted in our postmenopausal longevity. Why there are all these postmenopausal women around like me, still more or less coherent. Why our maturity is later, why our weaning is earlier than our cousins, how we could then colonize all these novel habitats that, of course, little ones couldn't possibly manage to feed themselves in. So really different from what we see in our close cousins. And now this hypothesis gives us additional correlated shifts that go with longevity, our bigger brains. The shift in sex ratio in the fertile ages supplies hypotheses about our pair bonding habits, and this set of challenges to infants as a way to understand why we do stuff like what I'm doing right here, which is trying to, do you see what I'm saying? Can we get on the same page? Can we connect with each other? That begins to start in infancy in human kids, and the hypothesis that started with the life history change to explain the longevity now encompasses a whole array of other possibilities. So now is such an interesting time to be studying the human-ape paradox.